Hey everyone, welcome to the first session of UTK You're Doing It Wrong. Thanks so much for taking the time out of your very busy schedules to come check this out. This is a tutorial series that I started when I was here as a student at UT. The goal was to teach different advanced skills in the different software that we use, so you have the opportunity to work smarter and not harder, fully understanding the tools that you're using. A little bit about me. Some of you don't know me. I was born in Nigeria, but I grew up in Nashville, and I started attending University of Tennessee in 2011. Next year will be 10 years since I started here. Whew, wow. And I got my Bachelor of Architecture here, and then I also got my Master of Landscape Architecture here in the 5+2 program, which I hear is now a 5+1 program. Lucky you guys. So I believe a designer should be versed in all tools available to him or her, so they are never bottlenecked by the lack of knowledge of any specific tool. So it's important to be in the know. And that's the whole goal of the tutorial series that I've started. There are over 11 videos, each over an hour long, with content on the YouTube channel already. I'll share details about that at the end, that cover programs from Rhino and Revit to Grasshopper and Dynamo to GIS, Photoshop, Illustrator, InDesign, the whole gamut. So it's been really fun. The first session today will be on Revit and Rhino and their integration. So I'm going to be talking about Rhino and Grasshopper so you can fully understand how these tools work. And then we'll talk about how you can actually start using them with Revit, because Rhino has strengths and Revit has strengths, but to only use one is not the most efficient thing in my opinion. And lots of professionals are finding ways to use both for their different strengths. So we're going to talk about coding in Grasshopper. We're not going to necessarily build a script, but I will talk about the thought process behind scripting so you can kind of get what we're doing. And also introduce Revit and how BIM works. So we'll go through the presentation and then we'll jump into the actual programs. So the tools in this session: Rhino, Grasshopper, and Revit, and how we can actually start working together with some new tools that we'll be talking about, which is very exciting. It's always important to start with the fundamentals because you never know where people are starting from in terms of their knowledge of the software. So when you understand the fundamental basics, you can then understand how you can modify those. So we'll talk about the two major file types that we work with as designers who work in graphics. You have raster files, and raster files are basically pixels. And each pixel is a small square of color information. And when you get enough of those together, you create an image. So every screen you've ever seen in your life, including old TVs from way back when, are composed of pixels. Pixels are fixed. So once you have a pixel count, you can never get more. And if you lose it, you can never recover it. So the higher the pixel count, the better. And we also have vector files. And vector files are actually mathematical equations that your computer runs in order to create the vector graphic. The benefit with vector graphics is that they are infinitely scalable. So you can blow it up to the size of a billboard or shrink it to the size of a quarter and it'll still look sharp, but it is more computationally intensive. So just note that the raster file that you're working on in Photoshop will be less graphically intensive than the Illustrator document with tens of thousands of vectors in it. So that's important to note. So today we'll be looking at vector information pretty strictly, but there are other tutorials that talk about raster files, including tomorrow's session on Photoshop and Illustrator, which I expect to see all of you at. So we'll be talking about that stuff tomorrow. So what is a vector? So mathematically, a vector has two definitions. The first definition is a magnitude and a direction. So point in a certain direction, and then how long, the length is the magnitude of the vector, right? So that's a vector that starts from a single point and goes out in a certain direction. The other definition is a connection between 2 points in space. So knowing these two definitions, you can learn a little bit how you can manipulate the vectors that you're using in your designs. And this will be very important when we get into scripting vectors and in terms of defining what a vector is or being able to modify a vector based on its endpoints or any points in between, or it just giving it a direction and saying, go this long in this direction. So using vectors in Rhino, the most simple form of a vector is a point. That's not actually a vector, it's a single plane. But when you get 2 points together, you create what Rhino calls a curve. Usually curves are lines, but not all the time. So like Squares are rectangles, but not all rectangles are squares. Lines are curves, but not all curves are lines in terms of definitions in Rhino. So if you have a curve and it has a curve to it, then it is not a line. But if you have a line, it is still considered a curve in terms of Rhino geometry, but it is straight. So just note that. Now, another really important thing about curves is that they're actually infinite extrusions of points. So you can extract a point from any location along that line, which is how you're able to divide lines any number of times. So divide it by 10 or divide it by 20 or divide it by 40. It's because those points actually exist somewhere along the line. And surfaces are the same way. So a surface is an infinite extrusion of curves in both the U and V directions. So you can extract a curve from any location along that surface because those curves actually exist in the surface. And same thing with points. You can extract a point from any location along that surface because it's comprised of infinite points and infinite curves. Then you get mesh geometry, which is very different. Mesh geometry is comprised of polygons, either 3-face polygons or 4-face polygons. Meshes are computationally easier than NURBS geometry. NURBS geometry is what Rhino uses. But with mesh geometry, just note that instead of it just being a series of lines, it's a series of faces. And it just has to be computed differently. Typically, every video game you've ever seen, every CGI graphic in a movie is comprised of mesh geometry because it's just easier to manipulate. And the simplest form of a mesh is a triangular mesh. And that's the simplest form of 3D geometry you can create. But we'll be working with NURBS and curves since it's much more fun to do that. Degrees. So degrees determine the level of curvature in a curve. So the more degrees you have in your curve, the more levels of curvature you'll have. So a 1-degree curve is a line, and it will always be a line. When you get to 2 degrees, you can actually start defining a curve. And typically, we work in 3 degrees. So you can define 2 or more curves in a 3-degree curve. So just note that if, for example, if you're rebuilding a curve and it says degrees, it's typically 3. If you add more degrees, you can add more levels of curvature. But 3 is typically the basic or the standard. All right. So let's talk about parametric. What does that mean? So you hear that term thrown around a lot. This is a parametric model, or that's a parametric building and it looks all wavy and curvy and it's looks like Zaha Hadid designs. There's much more to it than that. So parametric, you could use it for synonyms like coding, scripting, algorithms, computational design, visual programming, node-based programming. But it basically boils down to the relationship between geometry. So making a change in a geometry over here will affect the geometry over here. Or a parametric workflow, meaning affecting a change early in the process, that change will then ripple throughout the process and affect other changes later on. So think of it as a relationship between objects and geometry and relationships over time and over a workflow. What is Grasshopper? So Grasshopper is a parametric modeling tool that uses node-based logic. So typical coding looks like this, right? Lines of code that you're typing that run a series of commands. Well, Grasshopper uses nodes. So it basically compresses this code into a node, which is much easier for designers to jump into and get the power of scripting without having to learn that you need to use a bracket here, you need to put a semicolon here, you need to make sure you spell that correctly or it breaks. Node-based coding hides a lot of that away, so you can still get to that power. And we'll talk about some of that stuff a little bit later. But just note that node-based coding allows you to get to the power of coding and skipping the learning curve that comes with the number of languages like Python, C#, Java, HTML, a number of things that people use today. So these programs work together. So Grasshopper is a plugin for Rhino. It does not exist without Rhino, so you can't just open Grasshopper and nothing's there. So you open Rhino, then you open Grasshopper, and data flows between the two. So you making a model in Rhino, you can then edit that in Grasshopper and then put it back into Rhino, and that's a cycle that continues between the two programs. So plugins for Grasshopper further augment its abilities. Plugins like Kangaroo, which is a physics engine, allows you to model gravity and forces. or Lunchbox, which allows you to subdivide surfaces in a number of ways, creating brick patterns, paneling patterns, things like that. Firefly and Weaverbird, which allow you to really enhance the modeling capabilities that you have. There are a number of them. One of my favorite websites is foodforrhino.com, which has a whole catalog of those tools available. All right, so fundamentals of scripting. So if you understand this, you understand scripting and you can build your own scripts. This is very easy concept, but once you get it, you're like, okay, that makes sense. So all scripting starts with an input. What am I editing? What is the input? What's the start? What is the object? So what? Then you have a command or component that does an action on the input. So expand, move, array, distort, transform, any number of commands that you can think of. And then you get an output, right? The resultant object based on the change or the commands that you ran on it. The power of scripting comes from where you take the output of one command and then it becomes the input of another series of commands. So you can link a workflow together. So it's stuff you're doing already. You just don't know it. You're the computer and you move a point and you take that point and you extrude it. And then you take that extruded point and then draw another line from it. So you're doing the same thing by yourself, but in order to tell a computer to do it, you need to link the workflow in that way using commands. So this is where the power of scripting comes from, and this is why I love Grasshopper so much. And it's much more than creating wavy towers and buildings. It can be as simple as, I have a curve here. It looks closed, but Rhino's telling me it's open. How do I find the gap? You can use scripting to do that, and I can show that example. Powers of parametric design: 3D modeling, node-based coding, parametric design, form generation, mask finding, adaptive component placement, lots of advantages. And when you understand parametric design, you need to understand that building a script is very slow because you're running into bugs, you're running into all the things you need to account for. You need to actually build it and it needs to work consistently. That part of the process is slow. But once the script is done and the workflow has been created, it's very fast. So you can use the script to generate a lot of geometry on the back end. So in a typical workflow, when you're the computer and you're the person doing the work, you're typing in move and you're boolean something out and you have to do that process again, that's where the time comes in. So you're like, oh, I have to do that process again and again each time I make a change. Or I can build a script. It takes time to build the script, but now that the script is done, I can generate a lot of geometry after the fact. So that's where the speed advantages come in when you're using parametric design. Okay. So extracting data from geometry. So every object you model has a lot of data that actually are required for that object to exist. So where does it exist in plane or in space? What's its X, Y, and Z information? What's its area? What's its volume? What are its edges and its vertices? So with every object, note that you can extract information or data from that object. You can run commands like area. And in order to get the area of an object, it actually runs a series of commands that actually gives you the center point. So now you have the center point of the object just by running the area command. And from the center point, you can then extrude a line from it or get the normal of the surface. And a normal is just the perpendicular direction off a surface. So it's always perpendicular to it. And normals are super handy when you're doing things like extruding objects off of a curved surface, right? Not every object can point it in the Z direction and it looks right, but every object can point in its normal and then the extrusion works correctly. So there are a number of things you can do with that, but just note that every object, you can extract data from that object. And there are key points that I'll show you that becomes very important. Data structure. So this is a little hard to understand, so bear with me, but if you get this point, you can really manipulate data that you're working with. What you're doing when you're parametrically modeling is you're manipulating data. So you're moving data from one component or phase into another. So for example, let's say you start with this input rectangle or cube or box or mass. And let's say you explode it into its 6 faces. You've now created a data tree. So the initial 0 represents the first box. When you explode it into its 6 faces, you move it into a tree. So the tree will then start having branches. So you can see its 6 faces are represented by these points here. So the initial object here is now split into 1, 2, 3, 4. In this case, yeah, there's 6 faces. All computers start counting at 0. So even though it says 0, 5 here, it started counting at 0. So 0 is actually the first object. So that's just a weird thing computers do. So we have the initial object, and then we have the 6 faces of that object that exists in the first branch of the tree. And let's say you take one of those faces and you divide it into 5 sections. You now have a third branch to that tree. So that third branch represents this guy right here. So this face has now been divided 5 times. So just note that if you want objects from this tree to interact with objects in this tree, you have to change the list structure. And that involves using tools like grafting or flattening in Grasshopper. And if you use Grasshopper before, you've run into those issues. Or also shift paths. That's a very useful command to say, I don't want to flatten it all the way down to 1, and I don't want to graft it so I have 30 objects. I want the 5 objects to then interact with the 5 objects before. So you can use shift paths to shift in between different branches in the data structure. So I hope that was clear. But yes.
Whenever you runtime wise, is it better to have things flattened graph or just already is given?
It depends on what you're trying to do, and it depends on the component. So sometimes you do need to flatten a list. But let's say I'm working on 2 towers at the same time. I want everything I'm doing on those 2 towers to happen independent of those towers. Independent of the other tower. So in that case, I'll want a grafted list that treats each tower differently. But if I want certain elements of one tower to interact with certain elements of the other, I would flatten that list. So Grasshopper looks at those 2 towers as the same object, basically, if that makes sense. So I'll show you an example of that. But it basically just means like if you've got 2 elements here, a flattened list would treat them as one, but a grafted list would treat them as 2 individual objects. So it's going to move both of them in the same amount. It's going to explode both of them in the same amount and treat them totally separately. But I don't have to have 2 separate move components to work with it. Both objects can be run through the same move component, and it'll treat them both the same way. So I'll show you. It's kind of a little bit difficult to understand, but once you do, it'll make a lot of sense in terms of how you understand it. So let's actually go through this example. So this is a simple move component. So let's break down the script here so it makes sense, right, in terms of the stages. So we have the input point to the left, and Grasshopper always reads from left to right. So we have the input point here. We're then running it through a command called move. Move is requiring 2 inputs. So it's requiring the object and then the motion. In this case, I want to move it upwards in the Z direction by 10 units. So the component's asking, okay, what do you want me to move and by how much? So I want you to move this point in this direction by 10 units. Grasshopper will use whatever units Rhino is using. So if your Rhino is in feet, that's 10 feet. If it's in inches, that's 10 inches. And then it's spitting out the moved point in this component here. So point, move in the Z direction by 10 units, output point. So let's do it. So let's go into Rhino. I'm going to launch Grasshopper. I should have launched this before because I have a lot of plugins in my Grasshopper, so it just takes longer. But for you, it'll probably be really fast. So we'll do this example, then we'll talk about Revit and what Revit does, and then we'll look at how they integrate with each other. So I'm not necessarily showing you how to use each tool, but how to use them together. Yeah, it's a very important distinction. If you want to learn them, like there are tons of videos, including my videos that dive deep into each one. Okay. Let's create our components here. So this is Grasshopper. If you've never seen it before, it's a floating canvas that exists alongside Rhino. So I'm actually going to snap one on one side and the other on the other side. Got some geometry here for a tower, and I'll show you that tower as well. But anyway, I'm going to create a point in Rhino. I'm then going to reference that point in Grasshopper. So I'm double clicking inside the canvas to initiate typing. And then I'm going to type in point. And so now Grasshopper is saying, okay, you've created a component here. It's orange because it has no data. And orange represents a warning. In this case, floating parameter point failed to collect data. I have no data, so I'm not doing anything. That's why it's orange. So in order to reference this point to this component, I'm going to right click on the component and go to set one point. And then it's going to ask me point object to reference, this one. And now that point has been referenced, and you can note that that point now has an X around it. It's green because I've got it selected. When I don't, it'll be red. So now that point's in Grasshopper, and changes I make to this point will then be reflected in the canvas. Now note that Grasshopper, any geometry that you see inside Grasshopper is virtually represented in Rhino. So it doesn't actually exist in Rhino until you run a command called bake, which will then take it from Grasshopper into Rhino. But then it separates it from the script. So I'll show you what that means. So I'm going to create my move component. So I'm going to type in move. So we've got move here. Again, it requires 2 inputs. Not every component requires all of its inputs to have something in it for it to work. Sometimes you plug something in and it'll automatically have a default value. So we'll plug point into geometry. And then we'll type in unit Z, which is the direction I want it to be moved in. And then I'll create a number slider. There are a few ways to do this. You can either type in number slider, which is not my least favorite way, because when you do that, it'll give you a set number slider that goes from 0 to 1. In this case, I want it to go to 10. So I'm just going to type in 10 and it'll create a number slider that goes to 10. Or if I type in 40, it'll give me a number slider that has 40 as a start, but it'll go from 0 to 100. And if you want to change the bounds of a number slider, you double click on it. And then you get the number slider settings where you can set its minimum number, maximum number, increments, whether it has decimal point values after it, or if it's a solid just integer. You can change a number of things about it. In this case, we'll just use this one that goes up to 10. And then you'll see that my point has been moved up 10 units. Actually, we might be too zoomed in to see it. We're in feet. Okay, so let's zoom in quite a bit. There it is. Okay, so there's our moved point. Now note that it hasn't actually moved the original point. It's created a copy because the original point needs to exist for the script to work in the first place. So I actually have 2 points now. And that means I can do really cool things with both of those points. For example, I can draw a line between them. And there are a few line components here. I just want to quickly show you the difference between them so you understand. Right now we're drawing a vector, right? So line, SDL. So there are 3 types of line components. The first one is a component that references a line that already exists in Rhino, similar to the point component. Then you get the line component that requires you to give it 2 points in order to create a line between those 2 points. And then you have a line component that requires a start, which is the initial point, a direction, and a length. So similar to the vector direction I gave you. So magnitude and length magnitude is the length and then the direction. So these are 3 ways to reference a curve or a line in Rhino. In this case, we're going to use this guy. And now we have a point or a line between those 2 points. And that line can be, since it's parametrically linked to the 2 points, the line will change when the points change. Line SDL would just require 1 point. And let's say a direction unit Z. And then we would give it a length. So let's copy this guy. So copy, just move first, then hold Alt, which is different than every other program. Other programs, you hold Alt, then you move. In this program, you move, then you hold Alt. It's terrible. It's weird. But anyway, so with this, you can create a line that comes out of the point. It's actually going a different direction so you can see it. So let's go unit X. We'll plug 8 into X and then that into motion. Actually, what I should have done is, sorry, I'm going to disconnect. You hold Control to disconnect. I'm going to plug that into length. That's what it's asking me to do. So the direction is unit X and then length is here. So With one point, you can generate a line using line SDL. So that's very simple. Does that make sense? This is how Grasshopper works. This is how you can do things like build towers from scratch in Grasshopper. So these 4 components here, this interior line represents a core. This exterior line represents the floor or the outer basis. And so I'll just open up a script that I built at the NOAA conference. And that video is online. So watch it if you want to see how you can build a tower from scratch. So I'll launch that here. And so this is a script that we're going to be using when we are looking at the integration of Rhino and Revit together. So right now the script is running, but there we go. So this entire tower was built using the initial elements that you see here. It's my favorite way to work because now if I want to make a change, all I have to do is go in. Let's say I want to grab the points of that curve. If I turn off the preview here and I move these a little bit this way, the script is now going to rerun and give me brand new geometry based on the curves that I have in here. Questions about that? Okay. So basically what the script is doing is taking the initial curve. It's then moving it a number of times to create the different floors, which I can then define. So 5 times, 10 times, 50 times to create the tower. It's then taking those floors, extruding them to make the actual floor thickness, and then also using them to create the outer facade. And then I'm using these panels that you see here to populate that facade. So I'm taking each face, dividing it a number of times, and then applying one of those panels, whether it's solid or it's glass, to the face. And you can do it a number of ways. In this case, I'm using a true false pattern or a true false false to create that pattern. Over here, it's the reverse. Over here, it's just one of the panels to create glazing on the north face. So you can really pattern the facade based on the different parameters that you use. So if you want to see me building this, check out the video online. But this is the freedom that Rhino gives you. And Revit, I'm not going to say it does not, but it's much harder to get to this level of parametricism in Revit. There is a tool that exists called Dynamo, which for a long time was the Grasshopper of Revit. But I'm going to show you something that's really cool that integrates both of them. But first, let's talk about Revit. So back to the presentation. Okay. So Revit, what is it and what does it do? So you've heard the term BIM thrown around a lot. Like, oh, I'm a BIM manager. All right, what does that mean? So BIM stands for Building Information Modeling. BIM basically combines data with 3D geometry. So the data that you can extract from a model include things like schedules or door schedules, which is just a list of every door in the building, specifications, documentation, materiality, and what those materials will do, costs, things like that. That's all building information that's built into the model itself. And so Revit does BIM. Revit does not equal BIM, if that makes sense. So Revit is a program that does BIM modeling, just like Vectorworks or ArchiCAD or Dynamo, right? These are programs that use BIM technology to do the geometry that you're seeing. So how does Revit work? So Revit ties everything that you see in it to levels. So levels will then represent the constraints that you're using. So level 0 will then be the floor. So the base of the building will be attached to level 0. And then each wall can either go up to a level, number 2, which in this case is 10 feet above level 1, or the second floor will go from level 1 to level 2. And so things are constrained towards levels. So let's say I then made this level at 20, then everything attached to that level will become 20 feet tall. So Revit does have parametric capability. It's just not like building a script in Grasshopper, like the base feature. But it is fundamentally a building information model is parametric. And then you also have views. And this is the major advantage of Revit is the ability to cut different drawings from a model. So getting plans at any elevation that you want. getting elevations at any location that you want, getting sections, 3D models, axons, all of those drawings can be comprised from that single model. So that's like that's the whole cell of Revit. And then of course it has all of the data in it. But this is a very powerful tool that I wish other programs had. But Revit is the one that does it the best, which is why it's the current industry standard and everyone's using it and saying, learn Revit. And you're just like, oh, but we don't have time. A number of things. So there are also components, and components are families. So families represent objects that exist in your model. So whether that's furniture, walls, floors, windows, those elements are called families. And so with a family, it's kind of like a block in AutoCAD or in Rhino. It's a model inside another model. So you can, for example, with this couch here, I can jump into the family and then edit its cushion sizes or edit its feet, which are models embedded in models together. So with components, you have a lot of abilities there. You can also bring models in and download models from different areas. And then you've got component families, and then you've got system families. So things like walls, floors, ceilings, these are all elements that are built into Revit. So Revit knows what a wall is. It knows what a floor is. It knows what a window is or a door is, which is different than Rhino. Rhino, it's just geometry. Rhino doesn't know the difference between the two, but the power of Revit is that it does know. But that means it also has constraints. So there's certain things you can't do to walls that you can do to floors. There's certain things you can do to floors that you can't do to walls. So in that way, it's inherently limiting in how it models. But in that way, it knows that with walls, it can create a schedule of all the walls in your project, which is very handy when you're needing to build something or you're needing to get costs of something. So its constraints are there, so it has additional power. It's not as free as Rhino, but it can do more things than Rhino can do in terms of documenting the project. So which software do we use? Age-old question, right? What do you guys think? All right, so we've taught you well here, right? The correct answer is both. Most firms will say Revit, and it's really sad. SOM is not one of them. I'm very thankful. We use both at SOM, very, very much. A lot of projects do start in Rhino and then migrate into Revit, but we're looking at ways to develop workflows that allow us to jump back and forth between the two. And McNeil and Autodesk are doing some really cool things to resolve this problem, and that's what we're going to talk about today. So Rhino WIP stands for Rhino Work in Progress, which is a beta version of Rhino 7, which actually allows you to run Rhino inside Revit and have the geometry work together. So pretty cool. We're not there yet. We'll get there in a second. So Rhino is great for 3D modeling, documentation, collaboration with consultants like MEP, structural, etc., and also getting schedules of a project. And then file formats. 3DM is Rhino, RVT is Revit, and then DWG is the almighty file format that every respectable CAD program can work with, including Illustrator. Including Illustrator. You can open DWGs in Illustrator, which is awesome. So all these file formats work together, and understanding how you can jump between them is a skill set that's very important to have. So that's the end of that. Let's jump into Rhino inside Revit, which is super cool. So I'm going to remote into my work computer because I don't have Revit on my personal computer because I rarely use it anymore. I'm a junior urban designer, and we also don't use Revit at all because it just doesn't solve our work for the scale that we're working at. So we use Rhino all the time. But the architects in our studios, they use Revit all the time, but they also use Rhino. And so we've, over like the past 10, 15 years that Revit's been around, we have built certain tools that allow us to kind of mimic this. But I'm finally glad that McNeil, who makes Rhino, and Autodesk, who makes Revit, are finally building tools that allow for a seamless integration between the two. So what you're seeing here is actually a model that was built in Rhino. As you can see, it looks like Grasshopper because it is Grasshopper inside Revit, which is super dope. So in order to get to this point, you need to have a license of Rhino 6. So if you own Rhino 6, you're good to go. And you download Rhino WIP, which stands for Work in Progress. And when you do that, it then allows you to install a plugin called Rhino Inside. And Rhino Inside is an open source project that they're doing to allow Rhino to exist inside other programs besides even Revit. So AutoCAD, Unity, Unreal, Illustrator. Some really dope things are coming, but one of the main ones, of course, is Revit. So Rhino Inside is dope. So download Rhino WIP and then Rhino Inside, and you can do some really cool things. So we'll look at how those two things integrate. So the way it works is you download Rhino Inside and Rhino WIP. You'll then get some new toolbars inside add-in. You'll see Rhino here. So it'll literally open a Rhino window inside Revit. And then you can open a Grasshopper window inside Rhino, which will affect Revit. It's super dope. So if you click Run Rhino, so this is a Rhino model, not open on my computer, but open through Revit. And you'll see a Revit toolbar appear in your Grasshopper window. So I've got that same script that I was working on that I showed you before. And so that is represented here. I can make, it's literally full Rhino. It works exactly the same way as normal Rhino does. So you can do things in Rhino. You can build your models here. And then you'll see those exact same models reflected inside Revit. And you can turn that Rhino geometry into Revit geometry. So you can add in the walls and actually specify what those walls are. So you can do the documentation together, but you can model in the program you'd prefer modeling in, which of course is Rhino. Because modeling in Revit is just, it sucks so bad, but it's so powerful. So this is kind of a happy medium between the two. So how does it work? Okay, so let's start from scratch. I'm going to delete this. And I'm going to close out of Grasshopper and Rhino inside of Revit. So we can start this from scratch. So close. And then close Rhino. So I don't have Rhino open on my computer as the standalone Rhino. Just have Revit open. If I go over to Rhinoceros, you'll see Grasshopper. So you can actually skip the Rhino. You can skip Rhino and go straight to Grasshopper. And open a script you've already built in Grasshopper and see it reflected in Rhino. So that script is here. I'm going to see if I can close this out so we see nothing. Okay, I guess it's still running in the background. I'm still learning this tool, by the way, because it came out like late last year, like October-ish, November-ish. So we're in the office. We're exploring how we can really take full advantage of this. But anyway, so you're basically seeing the Rhino Grasshopper preview in here. And you can open a file just like you would normal Grasshopper. So any number of files can work here. So let's open one that doesn't have a display. And then we'll close this out. So we'll have add-ins here. If you click this button, it will launch Rhino inside Revit. If you go straight to Rhinoceros, you'll see Grasshopper. So in this case, let's launch Rhino. So let's go over to add-ins, launch Rhino. I'm going to draw a cube here. All right, so that's a cube that exists in Rhino. You don't see it yet in Revit yet, but we'll look at how to do that. So let's bring Rhino back. So we're going to launch Grasshopper. And then you'll see you'll have a Revit toolbar. And this toolbar will only exist when you've opened it through Revit. So if you open Rhino normally, like Rhino WIP, you will not see this plugin. So you have to open it through Revit to get this plugin. And you'll see a number of things. You can build Revit floors using Grasshopper, Revit families, filters, geometry. You can make masses from inside Grasshopper. So you have that flexibility that Grasshopper awards you, but with Revit geometry. So I've got a script open here that I downloaded from the website. This website here, you can like download some sample files. So those sample Rhino files have taken some of the commands that are built in here and then scripted it out. So you can see here categories. These are like Revit category formats, which you can learn by watching Revit tutorials. So you can build things like columns, ceilings, floors, furniture, curtain walls. These are all things that Revit BIM technology has built in. So you can take advantage of that technology inside Grasshopper, which is awesome. In this case, we're just going to build a generic model. And what it's asking me to do is say, okay, take the Rhino geometry you want me to bring into Revit. So this BREP here, BREP stands for boundary representation. So it just means polysurface or a closed object or open. Open ones work too. So we're going to hit set one BREP. I'm going to click on that BREP there, the object. And then you just look into Revit. And I'll actually turn on the preview here. And then zoom out in 3D view in Revit. And there's my cube. And since it's linked together using Grasshopper, if I move the object in Rhino, let's turn on my gumball. It will move in Revit, which is super sick. So it's a live link between the two programs. So no more exporting to SAT and then bringing the SAT into Rhino Revit, which becomes a dumb object. You have a live link that you can use. So this is super powerful. So scripts that I've built here, I can now take advantage of all that power that I've already built in. So if I wanted, 10 floors or 20 floors, or 50 floors, I can do that. And then say, okay, take this one panel that I've built and then say, I want this one panel, to be fed into this Revit wall type. So every time it generates that geometry, it's going to become a real Revit wall. Yes.
Do you have to use Grasshopper to do this as well, or could it just be Rhino and Revit?
It can be Rhino and Revit, but Grasshopper is the live link. So just have it open and have the, this command here, this one, right? It's like 4 components that you can build in here. So you just set it in here and then it basically kicks the geometry over to Revit and updates it. So just have this script open basically and say, okay, great. Just kick it over, and then you can set the type. So if I want this to be a furniture piece or column, you can change it on the fly. So let's say you've built, the really complex geometry. So let's bring that component open, the one I had. And let's say, I want, so let's say I bake these walls here into Rhino. Just bake it to default for now. And I want these walls to now be inside Revit. So I'll select these guys, go to that other script, and then set these. And now they're in Revit. And I can then say, okay, set these to be whatever. And this is if you're using the Rhino-only Rhino workflow. But if you're using Grasshopper in Revit, you can then skip the whole, using the script component and go straight through it. So, questions? Yes?
So can we basically kind of think of the new Rhino, that as kind of a family editor of sorts?
Yeah. Yeah, anything you can do in Revit, you can now edit with Grasshopper, basically.
So if you move it in Revit,
yeah, you can go reverse too. You can go from Revit into Rhino. So you can bake the geometry in there, edit the geometry in Rhino, which is better, and then bring it back into Revit.
Yeah, so right now, how you convert everything to SAT, all that, and bring it into Rhino, and it's just bogging down to Rhino like crazy. Does this kind of simplify all that geometry and make it, if I were to take a whole model and put it into Rhino, would it now be allowed to?
Yeah, so you can actually be specific as to what you want to bring in. So let me show you a quick video that kind of displays that working. So what he's doing, and these tutorials, of course, are available to everyone. So you can see the script is being very specific as to what it's bringing in. So roofs, so he clicked roofs and he clicked the button, and then all roof geometry came into Revit, or Rhino. Gosh, having to be very similarly named is very annoying. but doors, walls, and it's bringing in simple geometry. So that's super powerful. That changes everything. Yes.
I just tried testing out the big. That's the way that you try doing the big. It only lets you do it through the Rhino layers.
Yeah.
How they not transferred over yet? If you mess with it, like how you want to do done in Revit.
Yeah, so it is definitely a work in progress. It's open source right now, so a lot of features are still coming out. I'm pretty sure there's a way you can go straight from Grasshopper into Revit. Like, for example, if let's pause the video. So if I bring that preview, where's Rhino at? So let's bring my tower script back up here. So you wouldn't use normal bake. You would actually use, let's say I wanted to just go straight from this guy. And this is a script that like works automatically. So I'm going to copy it and bring it into the other script that I'm working on. And this is one of the examples, like scripts that they have available on the website that's pre-built. So, but it's using the same tools that are in the toolbar. So instead of the brep that I set manually, I'm just going to clear this out and then plug in the geometry straight in. And so whenever I make changes, like you can see the whole tower here represented in the Revit window. And then I can just bring brep, plug that in, and then it'll automatically bake every time I make a change. And I'm actually curious if I increase the size of the tower. Let's hide the. So there's the Revit geometry that's coming from Grasshopper. I'm curious if I make a change. I haven't actually tested this yet. If I make this 5, the changes should ripple all the way through. It should look like it did. Or maybe I have to delete. The other one. No, I don't want to save. Oh, it's pinned. Maybe it has brought it in. That's what it is. It's this geometry. Yeah, so you don't actually have to delete. It's a live update. Other questions?
So the version that is inside of Revit adds, I guess, the typical Revit tool set, I guess you would call it, but a tab with commands that are associated, basically all the commands that you get inside of Revit.
Right.
Whenever, can you use other Grasshopper sorts of commands and scripting, and it's still jive with Revit? If that makes it like is it still work, or are you actually confined at that point where you should only use the Revit?
Yeah, so these are all the toolbars of the plugins that I have installed in Rhino, normal Rhino Grasshopper. They're available to me in Revit. So if you want to use a kangaroo component to generate geometry, you can do that now inside Revit. So everything is available. Of course, it's work in progress. That's why it's called WIP. So I'm sure there are some toolbars or plugins that won't work, but a majority do. If it's creating clean geometry, it should work. And you should be able to like, okay, lunchbox, give me a really dope, brick pattern on that surface and then turn that into real bricks in Revit. Or, use it to generate other geometry. So these plugins work inside Grasshopper, inside Rhino, inside Revit. And you can continue using normal Revit or normal Rhino aside, and any plugins you install will then become available because it's still using the Revit WIP that you have. So just switch to using WIP for everything. Like, I don't think anything you do in Rhino 6, if you're installing something, it'll show up in Rhino 6 and Rhino WIP together. Just think of it as like, Rhino 7.0 something. I forget the alpha names. Yes.
One thing I noticed about them is that, and mostly Revit, because that's what I use, is that when you create elements such as walls or ceilings or roofs or whatever, that they're always sort of extruded messes. And that, so there's no specificity that's documented inside of that, or that's at least modeled out. Is there maybe the potential or any desire to break it down to where there's actually documented modeling of framing members and of, of the structural elements, or is it still sort of at a place where walls are extruded masses?
Well, it's so if you model every aspect of a building, it'll crash your computer or it'll be super heavy. So the information is still there that it's a 4 by 2 by 4 with 8 foot spacing between them. It's just not going to model it for you to see it unless you turn on like detailed view or you go into a 2D drafting view and you represent it that way. But it's not going to draw the model at full resolution of the building. So the information is still there, and you can probably do more work in terms of like exploring these tools, but you can probably extract that information and use it as part of your Grasshopper script to do other things, which is like, it's so awesome.
Yeah, I know I've tried to like make maybe like a frame and an asymmetric sort of exploded framing plan. And whenever you build a model in BIM, you're left with just solid massive walls to where you don't really have that, or you just have to custom model it yourself.
Which I would still custom model it myself instead of using a wall and then saying this is what it is. If it's exposed trusses, I would build those trusses. But building, if it had any level of curvature, you're not using Revit to build it. You're using Rhino and then you're importing it. But with this, you can then say, okay, I'm going to build it in Grasshopper, which I would, and then skip the whole importing process and bring it straight in and just make it like a generic model. But that generic model, I can add in materials. I can get information from that. So like this is a game changer. This should have been out a long time ago, but they're finally doing it now. Yeah. Okay. Any last questions before we go eat dinner?
Yes.
Yes.
So, for instance, if you made a mass of a certain thickness and you wanted that to be a wall, and then in Revit you wanted to assign a specific wall type to that, would that change that back in Rhino? So
Rhino won't have access to that information. Okay. It'll still be just a mass in Rhino. But in Revit, through Grasshopper, Grasshopper is what adds in the information before it goes into Revit. So Grasshopper is always the mediator between the two programs.
So at that point, if you change the wall type in Revit, that necessarily wouldn't transfer back to Rhino?
No.
Okay.
Yet.
So when, like in specifically your example of like the tower, and I'm just assuming here it's like window and solid installations kind of, is it reading in Revit like a specific window family of the ones, or is it just like a generic like mass of windows?
So I built the script with no intention of it ever seeing Revit ever. So it's represented as just a simple like panel with a hole cut in it. So if I were to build this script now with the intention that it would end up in Revit, I would actually make all of them solid, but still separate them and then say, turn this solid shape and turn it into a Revit window using one of these components. And so then it would, exactly, right. So that's how I would do it. Okay, awesome. So thanks for coming. The next session will be on Photoshop Illustrator tomorrow at like 2, I think. So learning how to use those two together in a similar way that you did with Revit Rhino. It's just easier and you don't need additional plugins. It's just how they're designed. So that'll be very fun. And then Mind of a Maker is at tomorrow night, where I'll be talking about the work I do at SOM and a little bit of my background and some cool stuff that I'm working on today. So hope you guys can make it. Thanks for coming.